Good morning. Hope you're doing well. So this is Unit 4, Exponential Functions, and most of the introduction is going to be going over what we did in ninth grade. I hope you remember that particular project where you were working on money, figuring out how much money you have in X years, if you had a growth factor and a decay factor. But yeah, this is exponential functions. Even if you are not here in ninth grade, we're going to go over everything that you need to hopefully excel at this unit. So any real number x is an for any real number x, an exponential function is 1 in the form f of x is equal to a times b to the power x. A is not 0 because if a is 0, then your function is just f of x equals 0. B is any positive number, any positive real number. So b has to be a positive number. If this is not a positive number, then your function is not exponential. So it has to be a positive number, and it cannot be 1. Why can it not be 1? Is because anything to the power 1 to the power anything. If I have 1 to the power even a million, answer is still 1. So it can't be 1 because if it is 1, then the function is linear. It's no longer exponential. So the graph of an exponential function usually is going to look like this, right? It's going to look like what you see in here, graph of an exponential function. The domain is, I hope you can see that I have x values all the way going this way, and I have x values all the way going this way, or rather there is no x value that I can put here that would make the function undefined. So that means the domain is all real numbers, negative infinity to infinity. The range, if a is bigger than 0, as you can see in this question, and in this question f of x is equal to 2 to the power x, the value of a, I hope you can see the value of a is the number before the value of b, and the value of a is 1. So a is 1, 1 is greater than 0, therefore the range is all values from 0 going to positive infinity. You have y values for this function. You have y values, sorry, 0 is not included. 0 is not included because y equals 0 is a horizontal asymptote. If a is less than 0, then the range will be negative infinity to 0. You have a horizontal asymptote at y is equal to 0. Why, not y, is because the function approaches 0 as you go towards negative infinity. It doesn't touch, but it approaches 0 as you go towards negative infinity. You have a y-intercept at this point. This point is x is 0, y is 1. And what's interesting is that this value 1 is always going to be the same as the value of a in your equation. So your y-intercept is always going to be, for exponential functions, is always going to be x is 0 and the y value is the a value of the equation. So yeah, that's what we can expect from graphs of exponential functions. Example, if I have f of x is equal to 2 to the power x, and I need to find what the value of the function is when the input value is 3, so basically substitute for x as 3, then f of 3 is going to be equal to 2 to the power 3, and 2 to the power 3 is 8, so that's just 8. If f of x is equal to that, and I need to evaluate f of 3 again, then f of 3 is, remember, this means that the input value is 3, so I have 30 times 2 to the power 3. Instead of x, I input 3. 30 times 2 to the power 3 is the same as 30 times 8, and 30 times 8 is 240. Evaluate again for the value of the function when the input is 2. So when the input is 2, I'm going to substitute for x as 2 plus 1. This is multiplication. This is the same as 5 times 3 to the power 3, which is the same as 5 times 27. 5 times 27, 125, 165, I think. 165. Find the formula for an exponential function that passes through 3, 1, and 5, 4, and learn your answers to 4 decimal places if necessary. Now, going back, I know that my formula for an exponential function is supposed to be y is equal to a times b to the power of x. That's the formula for an exponential function. Now, fortunately for me, I've been given two coordinate points. I've been given an x value and a y value, an x value and a y value. So I can substitute these x and y values into this equation, the general form of the equation, and it will give me two equations with unknowns a and b. If I have two equations with unknown a and b, then I can solve them simultaneously. Let me show you what I mean. So in this equation, the y value is 1. Sorry, from this point, the y value is 1. So I'm going to substitute for the y value as 1 into this equation. 1 is equal to a times b to the power x. From that point, the x value is 3. So that is my first equation, Roman numeral 1 equation. The second equation I can make is if I substitute for this point into the general equation of an exponential function. So the y value is 4, substitute 4, is equal to a times b to the power x. The x value is 5, so put there 5. Then this is my second equation. Now, you can use substitution, you cannot use elimination, but one form of elimination you can use here, the elimination that you're used to where you multiply by something and subtract will not work. But the elimination I can use is to divide equations. If I divide equation 2 by equation 1, let me write this in blue. If I put equation 2 on the top, so equation 2 is a times b to the power 5 equals 4. And I divide corresponding terms by equation 1. Equation 1 is a times b to the power 3, and on this side, instead of equal to 1, I'll have 4 divided by 1. This is one way that I can solve this equation. I said you can use substitution if you like. That also works, but this is going to be faster for me, and therefore that's what I'm going to use. I might show you how to use substitution if if the universe allows it. So b to the power 5, I'm left with b to the power 5 divided by b to the power 3 is equal to 4 divided by 1. I know that b to the power 5 divided by b to the power 3 is the same as b to the power 5 minus 3, which is equal to 4. b to the power 5 minus 3 is the same as b to the power 2 equals 4, so therefore my b value could be positive or negative 2. Now remember that in the definition of an exponential function, we said that b has to be a positive real number. Since b has to be a positive real number, I can immediately say that my b value from this is only going to be positive 2, right? Because I'll discard the negative value. So going back to my equation is supposed to be y equals a times b to the power x, right? I have now got b, I still don't know what a is. However, I have an equation here, I have a simple equation here. Now you can use either one of these equations to solve for a. I can use this one or this one. I'm going to use the first one because this is a 1, so that will be easier to solve. So in that equation, 1 is equal to a times b to the power x to the power of 3, to the power 3. I know what b is 2, so I can just plug in 2. 1 is equal to a times 2 to the power 3. 2 to the power 3 is 8, so this is 8a equals 1. And if I divide by 8 and divide by 8, I can see that a is 1 out of 8. Now since I found the values of both a and b, I can finally write my equation in the form y is equal to a times b to the power x. And that equation will be y equals a, which is 1 out of 8, times b, which is 2 to the power x. That is my final equation. We can try and see what that equation looks like when I graph it. If I graph that equation, let's try and see what it looks like as this loads. So yeah, we'll come back to that when it loads. while we wait for it. Okay, so yeah, hopefully, oh, there we go. Y is equal to 1 out of 8 times 1 out of 8 times 2 to the power of x. If I graph that, then that's what my graph looks like. And just to remind you that the value of a is always going to be the y-intercept. And I hope you can see that the value of a, which is 1 out of 8, which is the same thing as 0.125, is the y-intercept for this graph. This graph, all exponential functions are going to have graphs of this shape, right? We told you a could be positive. I told you a could be positive or negative. So if this was a negative, then your graph would switch to look something like that, as if it's reflected over the x-axis. Remember, the initial graph was just, how do I duplicate this? There we go. The initial graph was this without the negative, and if there's a negative, then it's reflected over the other side. Yeah. So moving on to example 2. You can do this same thing on a graphing calculator. This one that I was using is for PC, but on your own graphing calculator, if you go to start and you go to list, then in your list you plug in the points, the x and y points. X is 3, y is 1, x is 5, y is 4. After plugging in those points, you go to start again, and then you click calc. On your phone, I don't think the option is number 0, but it should say exponential regression. You should look for the option that says exponential regression on your phone, but if you're using the school graphing calculator, then it will be number 0. And if you push enter, then it will give you the equation, exponential equation. It will give you the a value, and will give you the b value of those points, or of that data. All right. Find the equation for this exponential function. This exponential function has been graphed, and I simply need to find its equation. So this point here is the point x is 0, y is 3. And remember, I told you, we saw earlier in this example that this point here, this value of a is always going to be the y-intercept. And we saw the same thing on the graph, that value of a is going to be the y-intercept. So that's what we are applying here. If this is my y-intercept, then I automatically know that the value of a here is 3, right? The value of a is 3. Since I want to find the equation of this graph that's graphed here, I can look for another point. When I look at the axis, I see when x is 1 and y is 6 is another nice point, right? X is 1, y is 6. So I can use this point and this information that a is 3 to find the equation of the function. I know the general form of the equation is supposed to be y is equal to a times b to the power x. That is supposed to be the general form. So I know what a is. I have a y value from here, and I have an x value from there. So I can use those three pieces of information to find the value of b. When I find the value of b, I have my equation for the function. So let's do that. Y is 6, I plug in 6 is equal to a is 3 times b, which I don't know, to the power x, which according to this point, x is 1. So I have 6 is equal to 3b, because b to the power 1 is still b. If I want to find b, I divide both sides by 3, so b is equal to 2. Now my equation, I can write my equation as, remember, a times b to the power x. So my equation is going to be y is equal to 3 times 2 to the power x. And that is a graph that passes through 3, x is 0, y is 3, and then it has a shape like that. When I go to this and try to graph it, if I try to graph 3 times 2 to the power x, then it looks like that. Same graph has a y-intercept of x is 0, y is 3, passes through when x is 1, y is 6. So that is the same graph. That's just proving that we're on the right track. All right, let's talk about exponential growth or decay. This is again review of what we did in 9th grade, and we'll add on to that. So remember, the function can be of this form. B cannot be equal to 1, because if it's 1, then it's a linear function. A is the initial value or the starting point. This A is the initial value. And B is called the growth factor if B is bigger than 1. If B is bigger than 1, it's a growth factor. If B is less than 1, if B is between 0 and 1, not less than 1, if it's between 0 and 1, then it's a decay factor. Now, when you're dealing with percentages, just something to note, if you're dealing with percentages and you're told that something grows at a percent rate of maybe 14% per year, then to find the growth factor, you're going to have to add 100% to 14%, because this is an increment in already 100% of what it is. When you add that, you get 114%, and then to get the growth factor, you need to change it to decimal by dividing by 100, which is 1.14. So your growth factor would be 1.14. And the opposite is true. If something was decreasing at a rate of 14%, then since it's decreasing, you subtract it from 100 minus 14%, which gives you 86%, which when you change to decimal is 0.86. So this will be a decay factor. Alright, so let's do some examples. A scientist begins with 80 milligrams. Remember, here we found that A is the initial or starting value. So since that's the initial value, then I know already that this is A. It decays exponentially, good. After 20 hours, right? 20 hours, that's time. 20 hours is time, so this is going to be my X value. 40 milligrams of the substance remains, that is my Y value. So I have a point already, 20 and 40, and I have an A value, and they want me to find this. This is basically another Y value. So this is basically another point whose X value I'm trying to find. This is 45. So I've been given 1 point, and I've been given a starting value, which is A, and I've been given another value for Y, and I just need to find X. This is really straightforward if you can extract the information from the statement. So always start with what you know. Y is equal to A times B to the power X is the general form of an exponential function. What do you have? You have A is 80. So your equation simplifies to 80 times B to the power X, right? What else do you know? Well, we know that X is 20 when Y is 40. So substitute when Y is 40, I have X times B power 20. The only unknown that I have here is B, which I can solve for. Divide by 80, divide by 80, so I end up with 0.5 is equal to B to the power 20. If I want to find B, it's just as if you have X squared equals 4 and you want to find X, you take the square root, right? Well, if it was power 12, you take the 12th root. And since it is power 20, I'm going to take the 20th root. So since B power 20 equals 0.5, B is going to be the 20th root of 0.5. The 20th root of 0.5 is, using your calculator, you can look at your calculator and figure out how to do it. You probably have to push second function and the root of a number symbol. So the 20th root of 0.5, my calculator says that it is 0.9659, 0.9659. You should use at least 4 decimal places, because this being exponential growth, even a single decimal is going to lead to a big exponential growth. So at least use 4 decimal places. Alright, so I have my B value. I have A, I have B, life is good. all I need to now find is x. My equation now simplifies to y is equal to a, which I know is 80, times b, which is 0.9659 to the power x. If I have a y value, which is over here, I can definitely for sure find this x value. So I want to know how many milligrams remain after 45 hours. The y value is 45, that is 80 times 0.9659 to the power x. I'm trying to look for x. So again, divide by 80, divide by 80, right? How many? No, sorry. I got this twisted. I do not have x. I do not have y. I have x. Very sorry about that. This, what was given is I'm given the hours, and remember the hours are my x value, right? So I'm given the hours, and I need to find the y value. Okay, it's not that big of a difference. I need to find the y value. I have the x value. 80 times 0.9659 to the power of 45. So y, I'll just plug this in my calculator. 80 times that big number to the power of 45 gives me 16.82 if I round it up, 16.82 milligrams mass times gravity, milligrams, 16.82 milligrams. Alright, let's look at another one. The wolf population in a certain region has an annual growth rate of 4% per year. So as soon as you see this, you know that my growth factor is going to be 100 plus 4, which is 104%, which I need to write as a decimal before I substitute it, and it's 1.04. Alright, in the year 2020, there was 19,500 wolves. So this is telling me that this is a starting point, right? This is an A value because 2020 is when time was 0, is when they started counting. So in 2020, there were 19,500 wolves, and they want me to find out how many wolves there are in 2022. 2022, the time that has passed is 12 years. So my equation, start from what you know, is supposed to be A times B to the power x. Since this is time, I can say this is A times B to the power t. And I can even use letters that stand for what the information is in the question. For example, y is the number of wolves, right? A is the initial value of the wolves, so I can say W naught. B is the growth factor, so growth factor of wolves, I can just say G to the power t. You don't have to do this step. I was just trying to use symbols that are in line with the question. But your equation is going to be y is equal to A, which is 19,500, times B, which, do we know B? Yes, B is the growth factor and it is 1.04 to the power of t. And if I want to find out the wolf population in the year 2020, I just need to substitute for t as 12. So that's 19,500 times 1.04 to the power 12. And when you plug that into the calculator, 19,500 times 1.04 power 12, 31,220. I'm getting 31,220.13 rounded up wolves. The problem here is that wolves being natural things, a wolf is a natural thing, you cannot have 0.13 of a wolf or wolves or the team wolves FC. So the actual answer here is going to be 31,220 wolves, right? I round it up because I can't have 0.13 of a wolf. Alright, I hope that was helpful. If you have any questions, send me an email, send me a comment. If I take too long to respond, send another email. Alright, this is your homework. We'll discuss it in class tomorrow.